This is a video for AQA Further Pure Mathematics. This is Roots of Equations section 1.1, in which we're looking at the relationship between the roots and coefficients of equations. Well, we know that a quadratic equation will have two roots. Sometimes, of course, we need to consider the fact that the root will be repeated. However, let's take an example of one where we've got two distinct roots, x equal to 5 and x equal to negative 2. We can take the roots and therefore produce the factors of the equation by doing a subtraction. So x minus 5 multiplied by x minus negative 2 will be our quadratic equation equal to 0. The second of those factors we can change to being x plus 2 equal to 0, and then when we multiply that out we get x squared minus 5x and plus 2x, so a total of minus 3x, and then minus 10 equal to 0. I'd just like you to note at the moment that if we take the sum of the roots, 5 plus negative 2, we get 3, and if we take the product of the roots, 5 multiplied by negative 2, we get negative 10. So we have this now on a nice neat slide, so that we can note that there appears to be some relationship between the sum of the roots, giving us 3, and the coefficient of x, which is negative 3, and the product of the roots, negative 10, and the number term in the equation, which itself is negative 10. Now, of course, this is not a proof of this relationship, and for that we'd need to look at a general equation. Well, here's our general equation then, ax squared plus bx plus c equal to 0, with roots alpha and beta. The first thing to note is that the equation itself we can divide through by a to write as x squared plus b over ax plus c over a is equal to 0. If the roots are alpha and beta, we can write that as the product of x minus alpha and x minus beta equal to 0. And this time, multiplying out, we get x squared. Then the x term, we get minus alpha x and minus beta x. So a total of minus and then alpha plus beta times x. And finally, the term at the end is plus alpha beta equal to 0. So again, comparing these two equations, we can see that minus alpha plus beta must be equal to b over a, and alpha times beta, the product, is equal to c over a. Now it's usual to write the first one of these as alpha plus beta is equal to minus b over a. So they've got alpha plus beta, that's the sum of the roots, is negative of b over a, and the product of the roots, alpha multiplied by beta, is equal to c over a. So we think about that as the sum of the roots is negative of the x coefficient, and the product of the roots is equal to the number term at the end. And there we have it written out again nice and neatly. See with the equivalent relationship at the top, but we get this idea that the sum of the roots alpha plus beta is minus b over a, and the product of the roots alpha beta is c over a. Let's consider now a cubic equation, the general form of which is ax cubed plus bx squared plus cx plus d equals 0, and this time we'll have three roots, alpha, beta and gamma. Well, as before, we can write the equation as the product of the factors, so we can write this as x minus alpha, x minus beta multiplied by x minus gamma. And multiplying out the second two brackets produces the quadratic x squared minus beta plus gamma times x and plus beta gamma. Now just consider now what happens when we multiply out these two brackets. So firstly, you can see that we will get x cubed from the first two terms being multiplied out. If we now consider what happens with the x squared term, that comes from the minus alpha times x squared and then the x multiplied by the x term in the second bracket. So we get a total of minus alpha x squared minus and then minus beta and gamma x squared. So we've got minus of alpha plus beta plus gamma times x squared. Now for the x term, that comes from the minus alpha multiplied by the x term in the second bracket. So we get alpha beta and alpha gamma, and also then the x multiplied by the beta and gamma in the final term. So you can see here we've got the products, which are alpha beta, and then we normally write it as beta gamma and gamma times alpha times x. And then lastly we've got the term at the end, which comes from the minus alpha multiplied by the beta gamma, so minus alpha beta gamma equal to 0. So again then we see here that we've got the sum of the roots for the x squared term. We then got what we call the sum of the pairs-wise products of the roots, so two of the roots taken together, so alpha beta, beta gamma and gamma times alpha. And finally the product of the roots. Now to compare these again with what we need to do with the first equation is to divide through by a, and we get the following. And now we can compare the two equations, and we can see that the b over a is negative of alpha plus beta plus gamma, so the sum of the root is minus b over a. The pairs-wise product is equal to c over a, and the product alpha beta gamma is minus d over a. So we say that the sum of the roots is negative b over a times the x squared coefficient. The sum of the pairs-wise products is c over a, that's the equal to the x coefficient, and then the number at the end is negative of the product, so alpha beta gamma is negative d over a. So the two results for quadratic equations and cubic equations is what I wanted to consider in this video, but you might like to consider, well, what will happen if we go up to a quartic equation? What will the relationship between the roots here, obviously there will be 4 roots this time, what would the relationship be here? And then you might consider talking to your tutors about that. So that's the end of this video. In the next one we'll be using the relationships that we've just developed to calculate things about equations.